Hello and welcome to another video. Let's prove that if a raised to the power of x equals b raised to the power of y equals parenthesis ab raised to the xy, then x plus y equals 1. Now the first thing to do in this case is to set a raised to the power of x equals b raised to the power of y, and then take on both sides logarithm with base a. So from there we should be able to write an expression for x in terms of y. Now let's do that. Okay, so like I said, the first thing to do is to set a raised to the power of x equals b raised to the power of y. Then taking on both sides logarithms, okay, with base a. So this would be, so we can now have logarithm to base a of a raised to the power of x equals logarithm to base a of b raised to the power of y. Okay, now let's use the property now using the logarithmic property logarithm to base a of p raised to the power of n. This will be equals to the product of n and logarithm to base a of p. So this is the product rule for what? Logarithms. So this will become x log a to base a equals to y log b to base a. Okay, now also when we have the argument and the base to be what? To be the same, then the logarithm of the argument to base a will be equals to 1. So which means what I mean is that logarithm to base a of a will be equals to 1. So which means that this will be x times 1 equals y logarithm to base a of b. Okay, so this would be x equals to y logarithm to base a of b. So this is the expression for x in terms of y. Okay, now again, I'm going to set a raised to the power of x equals parenthesis ab raised to the power of xy. So that will be a raised to the power of x equals parenthesis ab raised to the power of xy, and then take on both sides logarithm with base a. So taking on both sides, okay, logarithms with base a. So this would be logarithm to base a of a raised to the power of x equals logarithm to base a of parenthesis ab raised to the power of xy. Okay, then again, I'm going to apply this property using the logarithmic property. Logarithm to base a of p raised to the power of n, okay, will be equals to the product of n and logarithm to base a of p. So in this case, this will be x logarithm to base a of a equals to xy multiplied by logarithm to base a of ab. Okay, now also we know that logarithm to base a of a equals 1. So this will be x times 1 equals xy logarithm to base a of ab. So this will be x equals to xy logarithm to base a of ab. Now let's expand this using the property, using the logarithmic property, log, that is the logarithm of the product of two quantities. Okay, so logarithm to base a of pq, that will be equals to the what? The sum, that's the sum of the logarithm of the two separate quantities. So that will be logarithm to base a of p plus logarithm to base a of q. So that this will be x equals to xy, okay, open parenthesis, logarithm to base a of a plus logarithm to base a of b. Okay, now also we know that logarithm to base a of a equals to 1. Then if we divide both sides by x, divide both sides by x, this will be x divided by x equals xy divided by x, parentheses 1 plus logarithm to base a of b. Okay, so this will be 1 equals to y into y, parentheses 1 plus logarithm to base a of b. Now, what to do now is to remove the parentheses. So I'm going to distribute y in this case. So this will be 1 equals to y plus, because y times 1 is y, then y multiplied by logarithm to base a of b. This will be y logarithm to base a of b. Now, let's go back to what we have here. We have that x equals y logarithm to base a of b. Okay, that is the product of y logarithm to and logarithm to base a of b. So which means we already have here that x equals to the product of y and logarithm to base a of b. So this will be 1 equals to y plus x. So therefore, x plus y equals to 1. Proven. The noblest pleasure is the joy of understanding. Bye-bye.